Welcome back to Click Future, where your future is a click away. Today we're diving into a breakthrough that could solve one of the most critical challenges facing our planet: energy storage. Quantum computers have just designed the perfect battery, and it's not just an incremental improvement. We're talking about energy storage technology that could revolutionize everything from electric vehicles to renewable energy grids, making fossil fuels obsolete within a decade. The energy storage problem has been the bottleneck holding back the clean energy revolution. Solar panels and wind turbines can generate clean electricity, but without efficient storage, that energy is lost when the sun doesn't shine and the wind doesn't blow. Traditional lithium-ion batteries are expensive, have limited capacity, and degrade over time. But quantum-designed batteries are changing all of that. Neil deGrasse Tyson recently observed that the quantum revolution in materials science is like giving a scientist a crystal ball that shows them exactly how atoms want to behave. We're not just improving batteries anymore. We're designing them from the quantum level up, creating energy storage systems that approach theoretical perfection. Today, we'll explore how quantum computers are designing batteries with 10 times the energy density of current technology, how these breakthroughs are already being implemented by major manufacturers, and why this represents the largest investment opportunity in the energy sector since the discovery of oil. To understand why quantum-designed batteries are so revolutionary, we need to understand the fundamental limitations of current battery technology. Traditional battery development has been a process of trial and error, testing thousands of material combinations to find improvements that are often marginal and take years to implement. The problem lies in the complexity of battery chemistry. A battery involves intricate interactions between electrodes, electrolytes, and ions at the molecular level. These interactions determine everything from energy density to charging speed to lifespan. Classical computers can model simple battery systems, but they struggle with the quantum mechanical effects that govern how electrons and ions behave in real battery materials. Charles Liu, the renowned astrophysicist, has explained that battery chemistry is fundamentally a quantum mechanical process. When ions move through an electrolyte or electrons tunnel through a barrier, they're following quantum rules that classical physics can't fully describe. It's like trying to predict the weather using only basic arithmetic. You're missing the fundamental physics. Current lithium-ion batteries face several critical limitations. They have relatively low energy density, meaning electric vehicles need large, heavy battery packs that reduce efficiency and increase costs. They charge slowly because rapid charging can cause lithium dendrites to form, which can short-circuit the battery or even cause fires. They degrade over time as repeated charging cycles damage the electrode materials, and they rely on rare earth elements that are expensive and often mined under environmentally destructive conditions. These limitations have created what energy researchers call the battery valley of death, the gap between laboratory breakthroughs and commercial viability. Promising battery technologies often fail when scaled up because the complex interactions between materials behave differently in large-scale manufacturing than in small laboratory samples. But quantum computers are changing this entire paradigm. Instead of trial and error, quantum systems can model battery materials at the quantum level, predicting exactly how different atomic arrangements will behave before any physical testing begins. The breakthrough in quantum battery design represents a fundamental shift from empirical testing to predictive engineering. Quantum computers can simulate the quantum mechanical interactions that govern battery performance with unprecedented accuracy, allowing researchers to design materials that were previously impossible to discover. The process begins with quantum algorithms that model how electrons behave in different material structures. These simulations can predict the exact energy levels, conductivity, and stability of materials that have never been synthesized. Quantum computers can explore millions of potential material combinations simultaneously, identifying the optimal atomic arrangements for specific battery characteristics. Brian Greene, the theoretical physicist, has described this process as quantum archaeology. We're excavating the space of all possible materials to find the perfect combinations that nature has hidden from us. Quantum computers don't just calculate faster. They explore possibility spaces that classical computers can't even access. The first major breakthrough came in solid-state electrolyte design. Traditional liquid electrolytes limit battery performance and can be dangerous if the battery is damaged. Quantum simulations identified new solid electrolyte materials that conduct ions faster than any liquid while remaining completely stable and safe. These quantum-designed solid electrolytes solve multiple problems simultaneously. They eliminate the risk of battery fires because there's no flammable liquid. They allow for much faster charging because ions can move through the solid structure more efficiently than through liquid. And they enable the use of lithium metal anodes, which have much higher energy density than current graphite anodes. The second breakthrough involved cathode materials. Quantum computers identified new crystal structures that can store and release lithium ions more efficiently than current materials. These quantum-designed cathodes can hold more energy in the same space while maintaining stability through thousands of charging cycles. Perhaps most importantly, quantum simulations revealed how to eliminate dendrite formation, the growth of metallic structures that can short-circuit batteries. By designing electrode surfaces at the atomic level, quantum computers identified surface patterns that guide ion flow in ways that prevent dendrite growth entirely. The transition from quantum simulation to real-world batteries is happening faster than anyone expected. Major battery manufacturers are already implementing quantum-designed materials in next-generation products, with some technologies reaching commercial production within the next 2 years. Toyota has announced that their quantum-designed solid-state batteries will be available in production vehicles by 2027. These batteries offer 500 miles of range with 10-minute charging times, representing a complete transformation of electric vehicle practicality. The energy density is so high that the battery pack for a full-size SUV weighs less than a current compact car battery. Tesla has partnered with quantum computing companies to design new battery chemistries for their energy storage systems. Elon Musk recently stated that quantum-designed batteries are the missing piece for sustainable energy. We're looking at grid storage systems that can power entire cities for days using renewable energy collected during peak production periods. The manufacturing process for quantum-designed batteries is also revolutionary. Because the materials are designed at the atomic level, they can be produced using precision manufacturing techniques that ensure consistent quality and performance. This eliminates the variability that has plagued battery manufacturing and allows for much more predictable scaling. Early production runs of quantum-designed batteries are showing performance that exceeds even the most optimistic projections. Energy density is approaching theoretical limits. Charging times are measured in minutes rather than hours, and cycle life is extended into the hundreds of thousands of charge cycles. The cost implications are equally dramatic. Because quantum-designed batteries use more abundant materials and require less complex manufacturing processes, they're projected to cost significantly less than current lithium-ion technology while delivering vastly superior performance. The environmental impact of quantum-designed batteries extends far beyond just cleaner transportation. These batteries are enabling a complete transformation of the global energy system, making renewable energy practical and economical at scales that were previously impossible. Grid-scale energy storage using quantum-designed batteries can store renewable energy for weeks rather than hours, eliminating the intermittency problem that has limited solar and wind power adoption. This means that renewable energy can provide baseload power, replacing coal and natural gas plants entirely. The economic implications are staggering. The International Energy Alliance estimates that quantum-designed batteries could create a $2 trillion market by 2035, representing one of the largest economic opportunities in human history. Countries and companies that lead in quantum battery technology will have enormous competitive advantages in the clean energy economy. Jana Levin, the cosmologist and science communicator, has observed that quantum-designed batteries represent a convergence of fundamental physics and practical engineering that could reshape civilization. We're not just talking about better gadgets. We're talking about the technological foundation for a sustainable future. The geopolitical implications are equally significant. Countries with advanced quantum computing capabilities can design and manufacture the batteries that will power the 21st century economy. This is creating a new form of technological sovereignty where quantum supremacy translates directly into energy independence. Investment flows into quantum battery companies are accelerating rapidly. Venture capital firms are investing billions in quantum materials startups, and established battery manufacturers are acquiring quantum computing capabilities to remain competitive. The quantum battery revolution is just beginning. Current quantum-designed batteries represent the first generation of what's possible when we can engineer materials at the quantum level. Future developments promise even more dramatic improvements in energy storage technology. Researchers are working on quantum-designed batteries that can charge in seconds rather than minutes, store energy for months without degradation, and even harvest energy from ambient sources like heat and vibration. These advances could enable everything from electric aircraft to space-based solar power systems. The investment opportunities in quantum battery technology are enormous and diverse. Pure-play quantum battery companies offer the highest potential returns, but also the highest risk. Established battery manufacturers investing in quantum technology provide more stable opportunities with significant upside potential. And technology companies integrating quantum batteries into their products represent indirect but substantial exposure to this revolutionary technology. For individuals, the quantum battery revolution means that electric vehicles will soon be superior to gasoline cars in every measurable way: range, performance, convenience, and cost. Home energy storage systems will make every house potentially energy independent, and portable devices will have battery life measured in weeks rather than hours. The timeline for widespread adoption is accelerating. What seemed like distant future technology just 5 years ago is now entering commercial production. The quantum battery revolution isn't coming, it's here, and it's transforming the world faster than most people realize. As we stand on the brink of this energy revolution, it's clear that quantum-designed batteries represent more than just a technological advancement. They're the foundation for a sustainable, abundant energy future that seemed impossible just a few years ago. The quantum revolution is solving humanity's greatest challenges, one breakthrough at a time. Thank you for joining us on Click Future, where your future is a click away. Next, we'll explore how quantum computers are revolutionizing artificial intelligence, creating AI systems that can think in ways human brains cannot comprehend. The convergence of quantum computing and artificial intelligence is creating possibilities that transcend our current understanding of intelligence itself. What are your thoughts on the quantum battery revolution? Are you excited about the potential for sustainable energy? Let me know in the comments below, and don't forget to subscribe for more insights into the technologies that are reshaping our world.